Sass class with Amanda. Hey. In this video, we'll discuss independent events. So first recall that we have the following rules for probability. First we have that for any event A, the probability is between 0 and 1. Then we have, if S is the sample space, probability of S equals 1, meaning the probability of any event in S occurring is equal to 1. If A and B are disjoint events, then the probability of A or B occurring is equal to P of A plus P of B. Then, for any event A, the probability of A not occurring is equal to 1 minus P of A. Okay? So remember, when we're thinking about this third rule, we can think of the Venn diagram. Pretend this is a perfect rectangle. This is my event A. This is my event B. And we're in its sample space S. Okay? These are disjoint events. This implies that when A occurs, B does not, or when B occurs, A does not. Right? Like flipping a coin. If we flip a coin, it lands one side on the table, then we're either going to see heads or we're going to see tails. We cannot see both at the same time. Right. So independent events are slightly different. Okay. So we can think of the following. Here's my event A occurring. And here's my event B occurring. Okay, so this tells us that in this portion, A and B can both occur. Okay, so independent events do not mean disjoint events. Independent events mean that both events can occur, but one does not influence the other. Okay, so independent events can both occur. So if A and B are independent, both can occur. But the occurrence of one does not influence or change the occurrence of the other. So, to determine when both occur, what we use is this other rule, A intersect B, right? Because this is the intersection, this area right here is the intersection of A and B occurring, right? So, probability of A intersect B, or A and B occurring, is equal to the probability of A occurring times the probability of B occurring. Okay, so this is now a fifth rule of probability that we can use. So let's just consider an example so you understand what independent events mean exactly. So let's say I'm playing basketball with Billy. And the probability that I make a basket is very small. It's 0.01. So I have my own probability of making a basket. The probability that Billy makes a basket is 0.8. So Billy is a much better basketball player than I am. So what is the probability we both score one basket? So let's say we're playing horse. If you're unfamiliar with this game, you and other players take turns making baskets from specific spots on the court. You take a shot. If you miss, you get an H. If you miss again, you get an O, etc. And so the better basketball player will have less letters from the word horse than the basketball player who is terrible. All right, so what do we know from this problem? Well, we know that the probability Amanda makes a basket is equal to 0.01. We know the probability that Billy makes a basket is equal to 0.8. Alright, so if I make a basket, it doesn't influence whether Billy makes a basket. And if Billy makes a basket, it doesn't influence whether Amanda makes a basket. So these two events, I make a basket and Billy makes a basket, are essentially independent because they both can occur, right? We both can skip a letter, and one does not influence the other. So to find the probability that we both score, we want to use this rule right here. So probability A and B is then equal to the probability of A occurring times the probability of B occurring. So it's very tiny because I suck. So that example was great. So now let's look at another example where I give you a series of events, okay, or of things occurring, and you can determine whether it's independent or disjoint, okay? So I'm going to make the list first, and you think about whether it's disjoint or independent, and then we'll go over them together. So 1. Disjoint or independent, the outcomes from flipping a coin. 2. The possible outcomes with respect to cream from untwisting an Oreo. Disjoint or independent. And then 3rd, let's say Amanda, your stats teacher, wears yellow. So this is one event. And let's say Rose wears yellow. Alright, independent or disjoint? Take a minute to figure it out. Alright, so number 1 should be relatively easy since we've talked about it and even used this as an example of disjoint events. So either you get heads or you get tails, you cannot have both. So that automatically makes them disjoint. Untwisting an Oreo. Disjoint or independent? Well, if you untwist an Oreo and the cream ends up on the left cookie, great. Or on the right cookie, great. But it can also end up on both at the same time. But the question is, does the occurrence of one have any influence over the other? Bring it to class. All right, Amanda wears yellow. Rose, some other person, wears yellow. So definitely these both can occur. And since I don't know who this person Rose is, this person wearing yellow and me wearing yellow are two different events that have no influence over one another. So we can claim that these are independent events. Alright, so if we're talking about independent events, we already know how to calculate the probability of A intersect B, or them both occurring. Well, what happens when we want to calculate the probability of A or B occurring? Okay, so before we needed A and B to be disjoint of one another, and we used this rule. But this doesn't work. Why doesn't it work? Let's look at a picture. Okay, so here's A, here's B. Well, if we want to know whether A or B occurs, and we add these two together, so here's the probability of A, and here's the probability of B. Okay, what's happening? Well, what's happening is that we're counting this twice, okay? So what we have to do now is subtract the probability of A intersect B in order to calculate this probability of A or B occurring. And remember, that is calculated as P of A times P of B when the events are independent. This is now our fifth rule of probability. But it should be noted that this rule works for any type of event. Okay, so Billy makes a basket or I make a basket is going to be the probability of Billy plus the probability of me minus the probability of A intersect B. And that was 0.8 plus 0.01 minus 0.008. And if you combined all of that, you get 0.802. Alright, and then the probability of T union H, if we're flipping a coin, these are disjoint, okay? So remember, these were independent. And remember that these are disjoint. But we're going to use this rule anyway. So that's equal to P of T plus P of H minus P of T intersect H. And so this is 1/2, that's 1/2. And they don't both occur ever. So this is 0. So the point of this is to show that you can use this rule for any set of events and it'll still work. So maybe you don't want to memorize both of them, but maybe just memorize the one. So in summary, we learned to define independent events and how to distinguish between independent and disjoint events. We learned 2 new probability rules. So if A, B are independent, then the probability of A intersect B is equal to the probability of A times the probability of B. And then, for any 2 events, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.